All right, Panthers, welcome to page 65. The other part of today's lesson is we want you to practice showing or proving that two functions are inverses. Okay, so on your white half sheet now, quite simply, as we said on the yellow sheet, to prove that two functions f and g are inverses, you must show that both f of g of x and g of f of x equal x. So the task is quite simply, again, I'm going to pull this off the paper while we're working with it. The task quite simply is to determine whether each pair of functions are inverse functions. So what I need to do is I need to find f of g of x, and I need to find g of f of x. And if they're both equal to x, then I'm going to say they're inverse functions. And if they're not both equal to x, then I'm going to say those are not inverse functions. So I've got these two functions. Essentially, this is not unlike a problem that we worked together on Monday. So let's start with f of g of x. I prefer to write it this way because I think it's simpler to see what you're doing. And I'm going to replace g of x with its rule. So f of g of x is f of 1/3 x minus 3. Okay. All I did was replace g of x with its rule. And now function f says whatever is here, multiply it by 3, and then add 9. So f of this stuff is 3 times this stuff, 3 times this stuff, plus 9. And now we're going to simplify that. If I distribute the 3 through, I'm going to get, 3 times 1/3 is just 1, so it's x minus 9. And then don't forget this plus 9 here. And the good news is that x minus 9 plus 9 is just x. So we got one of the things we need to be true that we've shown. What we now need to show also, squiggly, 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 is that g of f of x is also x. So g of f of x means I need g of f of x, work it inside out. F of x is 3x plus 9. Then function g says take 1/3 of whatever your input is and then subtract 3. So I need 1/3 of, 3x plus 9, and then minus 3. Now 1/3 distributed into this term, 1/3 of 3x is x, 1/3 of 9 is 3, and then I've got my minus 3. And guess what? That's also x. So, are these two functions inverses? F of g of x was x, and g of f of x was x. Yes, these are inverses. If you're asked to do this on the assessment today, you're going to have to show that work. You can't just say yes or no. All right, Panthers, let's try B. Let's try B. I've got two functions here again. I've got f of x is 2x squared minus 1, and g of x is the square root of x plus 1 all over 2. So here we go. I need to show you two things. I need f of g of x. Okay. F of g of x would be f of this stuff. Whoa. F of that whole radical x plus 1 all over 2. And then f says whatever the input is, square it, multiply it by 2, and then subtract 1. So I need 2 times this big old radical thing squared minus 1. Now, the thing here is that this big old radical squared, if you multiply the square root of something by itself, you're going to get the something. So you're going to get 2 times just the x plus 1 all over 2. If you multiply 2 by something over 2, the 2's cancel. So you get x plus 1. Don't forget the minus 1. And what's x plus 1 minus 1? It's x. Halfway home. Halfway there. Okay. Let's try it the other way. Let's try g of f of x. Well, g of f of x is g of whatever f of x is, 2x squared minus 1. And then function g says, whatever the input is, put it here, add 1, divide by 2, and put it all under the radical. So here we go. I got big ol' square root of 2x squared minus 1 as the input, plus 1 all over 2. Now, these parentheses can be dropped. These grouping symbols are not needed. So the plus 1 and minus 1 would cancel. I get the square root of 2x squared over 2. And the 2's divide out, which leaves me with the square root of x squared. And hey, what's the square root of x squared? It's just x. You don't need to worry about the plus or minus there. You're not solving an equation. You're just simplifying. So in a different example, we found another set of inverses, or another set of functions that are inverses, because I was able to show that both compositions made just x. All right, let's try one more example. Example C. We've got function L, gotta focus it. Okay, f of x is 4x squared. G of x is 2 times the square root of x. Let's see if they're inverses. F of g of x would simply be f of, well, whatever g of x is. So 2 times the square root of x. Gotta love those trains, right? Now, f says take the input, square it, and then multiply by 4. So I've got 4 times 2 square root of x squared. Does that equal x? Remember that the way to square a product of two things is to square them both. So this is 4 times 2 squared times the square root of x squared. Now, square root of x squared is x, but 2 times 2 is 4. So all this is 4 times 4 times x, or 16x. Panther's f of g of x did not equal x. We don't even need to find g of f of x. We had to hit both of those conditions to say they're inverses. So because f of g of x is not, like you might write in there, because it's not equal to x, because it doesn't equal x, these are not inverses. They can't be. Okay. Panthers, that's the basic idea. That's the thing you need to be able to practice and show. Here's what's left for you to do. Make sure, Panthers, in a minute you'll get access to the glue. Make sure that both of the ISN pages today are glued in, please. Both pages 64 and 65. Then you need to know what the classwork is for today, or the homework rather. So here is the new homework right here on page 396. It's 9 through 37, the odds. If you want to get a picture from my textbook, the green textbook, you're welcome to. Okay. You also need to know this, at about 2:10 today, you're going to get a chance to take a mastery assessment. And what's on the assessment? Well, as I mess up my camera, what's on the assessment? You're going to get your second chance to work on the roots and zeros of polynomials, S1, and then you'll get to work on S2, the learning target from this week's work. Okay. So what would you be wise to spend this time doing? Review in the ISN, review in the textbook, look back at homework, and especially look back at that old assessment. If you did a good job marking some feedback for yourself the last time you saw S1, that should help you today. Panthers, I'm sorry I missed you. I'm excited for what you're about to work on. Use this time wisely. Best of luck later on the assessment, and I look forward to seeing you all Friday. Have a great day.